Here's question 4. We've got a truck lift in a box. It tells us it's going to lift it 2.1 meters. It tells us that it's 57 kilograms, so we're happy with that unit. It tells us that gravity is 10. The gravitational field strength is 10. Calculate the gravitational potential energy, and it tells you what to do. Multiply mass times gravitational field strength times the change in height, which is 2.1. Put that all together, 1197 joules. And you could have written 1,200. It doesn't ask you for any significant figures or for anything sensible. So there we go. That's that one done. The next one, a cyclist with a mass of 70 kilograms. I'm happy with that unit. Moves at a constant velocity of 8 meters per second. Happy with that unit. Calculate the kinetic energy of the cyclist. So we know that kinetic energy equals half mv squared. So we're going to need to square this to 64. 8 times 8 is equivalent to 8 squared. And then we put that together. So 0.5 times the mass of 70 times 8 squared, 64, comes to 2,240 joules. Okay, next question. We've got a trolley at the top of the slope. It shows us that there. They're going to push the trolley, so a small little force is going to apply. So it just starts to roll down the slope. And then they repeat this for different angles called angle A. And we can see that here. Angle A is on the graph. It then says use the graph to estimate the time it takes for the trolley to roll down the ramp when the angle is 80 degrees. So what we can see is, well, this bit's missing at the moment here. So we're going to have to extend the line of best fit, then read off from the graph. So extend it, find 80, go across, and I've got 0.45 exactly. And the mark scheme says anywhere between 0.42 and 0.48. So that's that one. It then says do the same again, this time though for 45 degrees. So go up, go across, I get 0.54. Each of these are going up in 0.02s. So 0.54, and the mark scheme said anywhere between 5.3 and 5.5, 0.55. So that's that done. Quite a nice easy question so far. It then says the student had a choice of how to measure the time the trolley takes to roll down the ramp. And they've got a handheld stopwatch, or they could use light gates at the top or the bottom. They chose to use light gates because they're not idiots. So explain why this was the correct choice. So the crucial part of this is talk about human reaction times and talk about this is going to reduce systematic error in some way. And systematic error is error that we build into our method. So by not using a stopwatch and using light gates, we've improved our method. So the answer for this one, light gates remove human reaction times, 1 mark. And we can see that these are about 0.2 seconds, which is close to the 0.4 seconds on the graph, which we read off before. So this would make the systematic error large. If we had a time of 4.6 billion years, I don't need to use light gates quite so much, in that the systematic error then is going to be really small as a percentage. And that's that question done.